In this video, we're going to talk about how to make your own probability game. So we're going to look at making a game similar to the game in number 3, which is number 3 from the first section of this activity. So we have a spinner numbered from 0 to 5, and each of the 6 numbers is as likely to come up as any other. A player bets $1 on any given number, and you win $4, and you get your $1 bet back if you choose the correct number. Otherwise, your $1 bet is lost. So I'm going to show you the game that I came up with. I think it's a really good idea for you to try to come up with your own game. And what you want to think about in terms of coming up with a game is how much you're going to give in terms of a payout, and also how much the player might lose if they lose. And generally what you want is you want to have a bet at the beginning rather than have the person pay at the end. And that's because if people know that they have to pay when they've already lost the game, then you might need more security to enforce that in your casino. So the game that I am going to play is going to involve cards, playing cards. So I'm going to have a $1 bet to play. And what you're going to do is draw one card. And then the way I'm going to set my game up is that if you draw a number card 2 through 10, you lose. So you lose your $1 bet. If you draw a jack, you win $1, and you get your $1 bet back. If you draw a queen or a king, then you're going to win $2 and get your $1 bet back. And if you draw an ace, you win $3 and you get your $1 bet back. So that's the game that I have set up. And when thinking about setting up a game, you want to think about the probability of that things can happen. And then you also want to think about what the expected value is going to be. And so the idea here is to make a game that is a random game that doesn't involve a thinking choice on the part of the player. So games like blackjack and poker, where people have to kind of know things about, they're making a choice in the game about whether to stay or draw more cards. Those are a little bit more complicated. You want a game where what happens is totally random. And so roulette is a good example of a casino game where it's totally random. You're choosing a color or a number, you're putting your money on that, and then the wheel spins, and whatever it lands on is what it lands on. There's no skill involved in roulette. So I want to calculate the expected value of my game from the player's point of view. And there's actually 4 possibilities here. So I'm going to add some rows to my table, or columns, I should say, to my table. And so the first possibility is that you're drawing a number 2 through 10 and losing your $1 bet. And so since you're the player, that makes you at minus $1. And the probability of that happening is 9/13. So there are 36 cards in the deck that are the numbers between 2 and 10. And 36 out of 52, 36 out of 52 can be simplified to 9/13. Or you can just think about each suit has 9 cards in it that are the numbers 2 through 10. And there are 13 cards in each suit. Either way, that's going to be the first possible result. Second possible result is if you draw a jack. So there's a 1/13 probability that you draw a jack, and that result is going to be a positive $1 for you as the player. So you are making $1. You paid $1 to play, and you are getting that dollar that you paid back. So that washes out, plus you win $1 on top of that. So a net result of $1. If you draw a queen or a king, that has probability of 2/13, and that's a net result of $2. And if you draw an ace, you win $3. So net result of $3, and again, you're getting your $1 bet back there as well. And that has a probability of 1/13. So to calculate my expected value, I'm going to multiply each result by the probability. So -1 times 9/13 plus 1 times 1/13 plus 2 times 2/13 and plus 3 times 1/13. So that is going to be -9/13 plus 1/13 plus 4/13 plus 3/13. If I add up the positive ones here, 1 plus 4 plus 3, that's 8/13. So -9 plus 8 is -1/13. And then as a decimal, since I'm thinking about money, that's going to be a negative 0.077 or -7.7 cents. So, when you are a player in a casino game, you have a negative expected value because the house always wins. So you may have heard that saying. This is where that comes from. The house always has a slightly positive expected value, and the player always has a slightly negative expected value. And it's usually a very small amount because you want people to play your game. Obviously, if there's a very small payout, then people are not going to be willing to play. But it's always going to be a slight negative expected value for the player, and that is how casinos and other such things make money, because they have a small positive expected value, and if the game is played many times, that 7.7 cents is going to add up to enough money for the casino to stay in business. So to calculate the expected value from the house's point of view, again, I need to add a couple of columns here. So the house has a $1 positive result if you lose the game, because they're taking your $1 bet and they're not giving you anything. And that's if you draw a number 2 through 10. So there's 9 of those numbers. If you draw a jack, the house loses $1 because they are giving you your $1 bet back, and they are also giving you the $1 that you win. So that's a net result of -$1, probability of 1/13. If you draw a queen or a king, the house loses $2 with a probability of 2/13. And if you draw an ace, the house loses $3 with a probability of 1/13. So for my expected value here, from the house's point of view, that's going to be 1 times 9/13 plus -1 times 1/13 plus -2 times 2/13 plus -3 times 1/13. So we have 9/13 minus 1/13 minus 4/13 minus 3/13, which is a total of 1/13, or a positive expected value of that 7.7 cents.